Bismillahirrahmanirrahim. Dear cadets, Assalamu alaikum. Today we will discuss the real life application of quadratic equation, where quadratic equation are used in our daily life, how we can use them in our daily life problems, or how we can uh, form equations of our daily life problems and then solve by quadratic equation. So come to exercise 2.7. The first application is find two consecutive regarding numbers. That is the first application in daily life. Find two consecutive positive integers whose product is 72. Consecutive means continuous. For example, 2, 3, 4, minus 5, minus 4, minus 3, etc. So if we consider consecutive integer, first positive integer, let that is equal to x. So second will be next x plus 1. For example, we take 4. So 4 plus 1, we get 5. These are consecutive. So by algebraic substitution, if first number is x, next consecutive will be x plus 1. Then according to the given condition, find two consecutive integers whose product is 72. So we take two consecutive x plus 1, whose product mean x into x plus 1 is equal to 72. Now simplifying this equation, we get x square plus x and transforming 72 to left side. We get a quadratic equation. Thus from real life problem, we form an equation which is quadratic. Now we solve this quadratic equation by any one of the three methods and obtain the required answer. So first, by factorization method. Making factor plus 9 minus 8. If we add, we get plus x. If we multiply, we get minus 72. 9 adds 72. So making factor, we get two factors. X minus 8, x plus 9 is equal to 0. It is already explained. So either first factor x minus 8 is equal to 0 or x is equal to 8. Second factor x plus 9 equal to 0 or x is equal to minus 9. So we take only positive integer. A is given in the question. Find two consecutive positive integer. If only integer is given, this means we will take both the integer, positive and negative. Now we take only positive number, ignoring the next one. X is equal to minus 9. So first integer x is equal to 8. Second integer become 8 plus 1. That is x plus. We already substituted as x plus 1. So putting the value 8 plus 1 is equal to 9. Thus we get two consecutive integer 8 and 9. That is the first application of quadratic equation in real life. Second, again with the integers, with the numbers, application in the numbers, the sum of the square of three consecutive integers is 50. Here we take three consecutive integers. Let the first is equal to x, second x plus 2, third x plus, second x plus 1, third x plus 2. Now according to condition, find the integer. So the sum of the square of three consecutive integers, sum of the squares. So square of the first integer plus square of the second x plus 1 square plus square of the third integer is equal to 50. Now simplifying this condition, we get a required quadratic equation. So simplifying, first x square, second a plus b square, expanding this by a plus b whole square. X square mean x square plus 2x plus 1 square 1. Next x plus 2 expanding by a plus b whole square. X square plus 2 into x into 2 plus 2 square minus 50 transforming to left hand side equal to 0. Now simplifying, x square and x square, these three x square plus next 2x That term become 2 to the 4 plus 4x, now constants, plus 1 plus 2, 2 square 4 and minus 50. So adding like terms, that become 3x square, now 2x plus 4x, 6x, 1 plus 4, 5 or minus 50 become minus 45 equal to 0. So 3 is common, divide the whole equation by 3. We get simplified form of quadratic equation x square plus 2x minus 15 is equal to 0. Thus from we interpret or we express the real life problem in a quadratic equation. Now we solve this quadratic equation and get the required result. So by factorization, again making factor of quadratic equation, we get 2 factor x minus 3, x plus 5 equal to 0. So either x minus 3 equal to 0, this means x is equal to 3, or x plus 5 equal to 0, we get x is equal to minus 5. So take x is equal to 3. Here the word integers, find the integer. Integers mean it may be positive, negative. We take both the cases. First take positive x. So first integer 3, second x plus 1 mean 3 plus 1 4, third 3 plus 2 we get 5. Similarly for x is equal to minus 5, first integer x minus 5, that is second minus 5 plus 1 minus 4, third minus 5 plus 2 minus 3. Thus we get two pairs of integers, consecutive integers. If we take positive, we get 3, 4, 5. If we get negative, take negative, we get minus 5, minus 4, minus 3, which are consecutive integer in both the cases, positive and negative. Now come to 3, another application of quadratic equation in real life. So this relates to area of a triangle or area of some spaces. So the length of prayer hall is 5 meter more than its width. Length of a prayer hall, that is 5 meter more. So we consider the lesser one. Width of the hall is equal to x. So length become, that is 5 more, it become x plus 5. More mean positive, less mean negative. Twice, thrice mean multiplication. So according to the given condition, 5 more than its width mean x plus 5. Now if area of the hall is 36 square meter, area is given, area of the hall 36 meter square. Find length and width of the hall. So using these conditions, we will get the length and width of the hall. So when the area is given, so it become rectangular. The prayer hall is, it become rectangle because width and length, width is less and length is 5 more. So area of the rectangle, that become length into breadth is equal to area. So according to the area of the rectangle, x into x plus 5 is equal to 36. So simplifying this condition, x square plus 5x and transforming 36 to left side, we get a standard form of quadratic equation x square plus 5x minus 36 equal to 0. Again factorizing, we get two factors, x minus 4, x plus 9 equal to 0. So either x minus 4 equal to 0, we get x4, or x plus 9 equal to 0, we get x is equal to minus 9. Here we take only positive integer because distance cannot be negative. We always measure the distance in positive integers, such as 2 meter, 3 meter, 4 meter. It cannot be minus 9 meter. Therefore, we take only positive result, that is x is equal to 4. By taking x is equal to 4, width of the hall become x 4 meter, and the length become x plus 5, which was already substituted. So x plus 5 mean 9 meter. Thus width of the hall is 4 and length is 9 meter. By multiplying 9 for the 36, which was given area of the rectangular hall. Another application in numbers, question 5. The sum of square of two numbers is 100. One number is 2 more than the other. Find the number. The sum of square of two numbers is 100. Their sum is 100. One number is 2 more than. So we consider let the first number is equal to x. Second 2 more mean that become x plus 2. Now according to condition, sum of the square of two numbers is 100 mean x square plus x plus 2 square is equal to 100. Expanding the brackets or the squares, we get x square plus, and that become a plus b whole square. That is x square plus 2ab, 2 into x into 2 plus 2 square minus 100, transforming into left hand side equal to 0. Simplifying, that become x square 2x square, and 4x plus 4x, next 4 minus 100. So that become 2x square plus 4x minus 96. Here 2 is common, so divide the whole equation by 2. We get simplified form x square plus 2x minus 48 is equal to 0. Again by factorization we get 2 factor, x minus 6, 6 plus 8 equal to 0. So either 1 factor x minus 6 is equal to 0, we get x is equal to 6. Or x plus 8 is equal to 0, we get x is equal to minus 8. So here again numbers, the sum of the square of two numbers is 101 number. There is no condition it is positive or negative. So we take for both the result positive and negative. When x is equal to 6, then first number 6, second number x plus 2, 8. So the numbers become 6 and 8. Similarly, when x is minus 8, first number become x minus 8, second number minus 8 plus 2 minus 6. So the numbers are 6, 8 or minus 8 minus 6. Now come to 6, again area application regarding area. So the area of a rectangular field is 252 square meter. The length of its side is 9 meter longer than its width. So again we substitute the width is equal to x and length is 9 meter more, mean x plus 9. So length of the hall become x plus 9. Rectangular field. So the area of the length of the rectangular field. Then according to the given condition, area given is 252 square meter or meter square. So according to condition, area width multiplied by length. So x into x plus 9 is equal to 252. Simplifying this condition, we get x square plus 9x minus 252. Again factorizing, we take 2 factor 21 and 12. By adding we get plus 9, by multiplication we get minus 252. So simplifying 2 factor, we get x is equal to 12 and x is equal to minus 21. Here we take only positive integer because distance between any 2 points, the distance cannot be measured in negative number, we take only positive number. So width of the rectangular field x is equal to 12 meter, we take positive value. And length of the rectangular field 12 plus 9 is equal to 21 meter. So we can check our result, length and width, that is 12 and 21. 12 multiplied by 21 we get 252 meter, which is the area of the rectangular field given in the question. Next 7. One side of a rectangle is 3 centimeter less than twice the other. So always we take first number. Let the width of the rectangle is equal to x. Then according to condition, what is the condition? One side of the rectangle is 3 centimeter less than twice the other. 3 centimeter less mean minus 3. Twice mean 2x. So that become 2x minus 3. 3 centimeter less than twice the other. So if first is x, second become twice become 2x, and 3 less mean minus 3. So given that area, in the question, area of the rectangle is 54 centimeter square. So according to condition x into 2x minus 3, then width multiplied by length is equal to 54. Multiplying the brackets, simplifying this condition, we get 2x square minus 3x minus 54 equal to 0. Or 2x square minus making factor of minus 3x. So 2 into minus 54 and again making 2 factor minus 12 and plus 9. Factorizing we get 2 factor 2x plus 9 into x minus 6 equal to 0. So either 2x plus 9 equal to 0 or x minus 6 is equal to 0. 2x is equal to minus 9 or divided by 2x is equal to minus 9 by 2. From the second result we get x is equal to 6. Again we take only positive because distance cannot be negative. So we take only x is equal to 6. Thus width of the rectangular field x is equal to 6 centimeter and length, putting in that equation 2x minus 3, value of x, 2 into 6 minus 3, 2 into 6 12 minus 3 become 9 centimeter. Thus width of rectangular field 6 and length is equal to 9. We can check this, we can check the result. Width multiplied by length 6 9 that is 54, which is given in the question. Now question 8, next. The length of one side of right triangle exceeds the length of other by 3 centimeter. If the hypotenuse is 5 centimeter, then find the length of the sides of the triangle. So since the triangle has 3 sides, base, perpendicular, hypotenuse. Hypotenuse is always greater, and it is given in this question. If the hypotenuse is 15 centimeter, mean let base is equal to x, perpendicular is equal to x plus 3, and hypotenuse given that is 15 centimeter. So by Pythagoras theorem, base square plus perpendicular square is equal to hypotenuse square. So putting the values base square plus perpendicular, we can take base and perpendicular. For example, we take x plus 3 as base, so perpendicular will be x. So we can exchange any one of these two sides by x and x plus 3. Because hypotenuse is given, it is always greater, so that is fixed. So using this formula, base square plus perpendicular square is equal to hypotenuse square. And we come of the form according to condition. Expanding this equation, we get x square plus expanding x plus 3 whole square by a plus b whole square. It becomes x square plus 2 into x into 3 plus 3 square is equal to 15 square 225. Or x square 2x square 2 3 is 6x plus 9 minus 225 equal to 0. Again simplifying 2x square plus 6x, 9 minus 225 become minus 216 equal to 0. Divide the whole equation by 2 because 2 is common. So we get the simplified form of quadratic equation x square plus 3x minus 108 is equal to 0. Or x square plus 12x minus 9x minus 108 equal to 0. So again take x common, we get 2 factor x minus 9, x plus 12 equal to 0. So by putting x minus 9 equal to 0, we get x is equal to 9. And x plus 12 equal to 0, we get x is equal to minus 12. Again we take only positive integer because distance cannot be negative, therefore x is equal to 9. That is base is equal to 9 and perpendicular x plus 3, 9 plus 3 is equal to 12. Thus base 9 perpendicular 12, that is length of the other side of triangle. Hypotenuse was given, we can check them by Pythagoras theorem. 9 square plus 12 square is equal to 15 square, that is 225. Next is 9, the same triangle. The sides of a right triangle in centimeter are x minus 1, x plus 1. Find the side of triangle. Side of a right triangle. So in a right triangle, if three sides of a triangle are given, x minus 1, x and x plus 1. So the longest side is always hypotenuse. Then remaining two we can change them base and perpendicular. So let the hypotenuse is equal to x plus 1 in these three sides. Base is equal to x, perpendicular is equal to x minus 1. If you take base x minus 1, then perpendicular will be x. We can change them. But hypotenuse is always the greatest side, therefore we take x plus 1 as the greatest number. Now using Pythagoras theorem, base square x square plus perpendicular square x minus 1 square is equal to hypotenuse square x plus 1 square. Simplifying the brackets of this expression, we get x square plus square of this one, a minus b whole square, x square minus 2 into x into 1 plus 1 square is equal to, on the right hand side, x square plus 2 into x into 1 plus 1 square, or x square 2x square minus 2x 1 square 1, and transforming this to left hand side, that become minus x square, 2x become minus 2x and plus 1 become minus 1 equal to 0. Again simplifying, 2x square minus x square, that is x square, minus 2 minus 2x minus 4x, plus 1 minus 1 cancel. So x is common, x minus 4 equal to 0. So either x is equal to 0 or x minus 4 is equal to 0. So we get two values, x0 and x is equal to 4. So when x is 0, we take first one. Perpendicular becomes 0 minus 1 minus 1. Hypotenuse 0 plus 1, 1. So we get other two sides minus 1 and 1. We take only positive measurement because distance between any 2 points should be positive. So distance cannot be negative, perpendicular cannot be negative. So we take the positive value. This is ignorable because by taking x is equal to 0, we get perpendicular minus 1, which is negative. So this is not the result. Ignoring this result, take x is equal to 4. So by taking x4, perpendicular become 4 minus 1, 3, and base is equal to x4, hypotenuse become x plus 1, 4 plus 1, 5. Thus we get three sides of a rectangle, 3, 4, 5. And we can verify them by Pythagoras theorem. Using this result, 4 square plus 3 square is equal to 5 square. We get the same result. The last question is this exercise 10. Question 10. A farmer bought some goods for rupees 9,000. If he had paid rupees 100 less for each, he would have got 3 goats more for the same amount of money. How many goats did he buy? So what is we are going to know? What is unknown in the question? First question is how many goats did he buy? So we suppose the number of goats and the price. So first let number of goats is equal to y, cost of each goat is equal to x. Or number of goat x, we can substitute any one of the variable. So let the cost of each goat is equal to x, because it is given a farmer bought some goats. So let the number of goats y and cost of the goats is equal to x for rupees 9,000. So if x is the cost and number of goat y, then according to condition we get number of goats multiplied by their cost is equal to 9,000. He bought for rupees 9, total amount is now 9,000. So we get 1 equation. From this, x is equal to divide both sides by y, we get x is equal to 9000 by y. Now next condition, if he had paid 100 less for each goat, 100 less for each goat, so price become x minus 100, because originally we suppose the price of each goat is x. So if he paid 100 less for each goat, that become x minus 100. Multiply by similarly, he would have 3 goats more for the same amount. He would have got 3 more. So we write, if the number of goats is y, 3 more mean y plus 3. N2 in the same amount mean 9000 is equal to 9000. We have second condition. So simplifying this condition, we get multiplying these two factors, xy plus 3y, plus 3x, next minus 100y minus 300 is equal to 9000. Putting the values of x and xy, because value of x we are known in xy in this equation. So xy is 9000. Putting in this equation 9000 plus 3, and value of x is 9000 over y minus 100y, this one, minus 300 is equal to 9000. Simplifying this equation, 9000 cancel with 9000, or 9000 minus 9000 become 0. So we get this one, 9000 into 3, 27000 by y minus 100y minus 300 equal to 0. 100 is common, divide both sides by 100. We get 270 by y minus 3 equal to 0. Now multiply both sides by y. To simplify or to remove this y. So we get 270 minus y square minus 3y is equal to 0. Writing in standard form, minus y square minus 3y plus 270. Make it the first number positive, or x square positive. Multiply by or divide by minus 1. The whole equation. We get y square plus 3y minus 270 is equal to 0. So this is a quadratic equation. We are going to solve this by factorization. Making factor, we get two factors, y minus 15 into y plus 18 equal to 0. So y minus 15 equal to 0, we get y 15, and from y plus 18 equal to 0, we have y minus 18. Since the number of goats cannot be negative, therefore we take only positive. Number of goat 15. So that is the requirement of the question. How many goats did he buy? So the farmer bought 15 goats. That is the answer. So that is the practical use of quadratic equation in daily life problems. Next come to review exercise. Review exercise, the same revision. It is very easy. So we take only those questions, solve those questions which are have some difficulty or some problem. So let question 7. Find quadratic equation whose roots multiplicative inverse of the roots of this quadratic equation. The given quadratic equation, and we will suppose we are required to get the equation whose roots are reciprocal or multiplicative inverse of the roots of this equation. So if alpha beta are the roots of this given equation, with the we compare this first of all with the standard form of quadratic equation, getting a is equal to 12, b minus 17, c is equal to 6. So if alpha beta of the roots of this equation, given equation, then sum of the root minus b by a. Putting the values, we get 17 by 2. Product of the root c by a. Putting the value, that become 6 by 12. Simplifying 6, 1 is 6, 6 2 the. We get 1 by 2. So according to condition, the roots of the required equation will be multiplicative inverse, mean if alpha are the root of the first equation given, then 1 over alpha will be the required. Similarly for beta, we get 1 over beta. Then sum of the required equation. sum of the roots of the required equation become 1 over alpha 1 over beta is equal to alpha beta LCM. We get alpha plus beta. Putting the values, alpha plus beta, that is sum 17 by 12 divided by alpha beta product 6 by 12. So again 12 12 cancel, 17 by 6 we get sum of the root. Similarly, product of the root 1 over alpha 1 over beta become 1 over alpha beta. Putting the values, 1 over alpha beta are 1 divided by alpha beta value 6 by 12. So that become 1 multiplied by 12 by 6. 6 to the 12 we get product is equal to 2. Thus required equation by putting the values of sum and product of the root into the formula x square minus sum of the root into x plus product of the root is equal to 0. So x square minus sum of the root 17 by 6 x plus product of the root is 2. 2 is equal to 0. Multiplying both side by 6 to remove this 6. So this implies 6x square minus 17x plus 12 equal to 0, which is the required quadratic equation whose roots are multiplicative inverse of the roots of the given quadratic equation. Next, question 11. Area of a rectangle is 48 centimeter square if length and width are each increased by 4 centimeter. Area of the larger rectangle is 120 centimeter square. Find length and width of the original rectangle. So given what is given in the question, area of the rectangle is 48. First of all, we write the original area of the rectangle is 48 centimeter square. Now we suppose for rectangle, width of the rectangle x, length of the rectangle y. So according to condition, width into length is equal to 48. We get one equation. Ry is equal to 48 by x. After increasing the sides given in the question, if length and width are increased by 4 centimeter, this means if first length is x, increased length is x plus 4. Increased width x plus 4. If first length is y, increased length is y plus 4. Now area of the increased or larger rectangle is 122 centimeter given in the question. So according to condition, increased width multiplied by increased length is equal to area of the increased triangle 120. Now simplifying this one, we multiply this by x multiplied by y plus 4 plus 4 multiplied by y plus 4. After simplification we get xy plus 4x plus 4y plus 16 is equal to 120. Putting the value of xy and y, we have already known xy value 48 and y this one. So putting in the given expression 48 xy 48 plus 4x plus 4 into value of y 48 by x plus 16 is equal to 120. Simplifying this term, 4x plus 192 by x, this one 4 into 48 plus 48, now constant term plus 16 and transforming 20 to left hand side minus 120 equal to 0. Or 4x plus 192 by x minus that become 48 plus 16 minus 120 minus 56 equal to 0. Now multiply each side by x plus x by 4 to remove this one. So we get multiply each by x by 4. 4 cancel, we get x square plus 48 minus 14x is equal to 0. Or in standard form, x square minus 48x plus x square minus 14x plus 48 is equal to 0. Now factorizing the quadratic equation, we get 2 factor x minus 6 is equal to 0. We get x is equal to 6. Or x minus 8 equal to 0. X is equal to 8. So width of the rectangle x is equal to 6 x and length, that is 48 by x, 48 by 6. So 6 8 the 48, that become 8. So width of the rectangle 6 centimeter and length of the rectangle 8 centimeter. We can check them by multiplying 6 8 the 48, which is given in the question. Area of the rectangle is 48 centimeter square. So that is the end of our today lesson. Thank you so much. Allah Hafiz.